Hello everybody, my name is Michael. The purpose of this video is to help you better understand the instantaneous rate of change of a sinusoidal function. The question that we will be looking at in detail is the following. The question is, compare the instantaneous rates of f of x equals sine x and f of x equals 3 sine x for the same values of x. What can you conclude are the values of x, and for which instantaneous rate of change of the two functions are the same? I'll give you some time to read it over. Okay, let's start this question by graphing it. I graphed 3 sine x in red and sine x is in blue. So we can already tell that it has the same instantaneous rate of change at pi over 2. This is because you can see both functions are parallel to the x-axis. We can already conclude that that's the only places where they have the same instantaneous rate of change is at 2 pi, or other words, their peaks. Also, we can, by seeing it graphically, we can also see anywhere else on the graph is the function in red is 3 times larger than the blue function, and this is due to the amplitude. The amplitude increases the tangent line 3 times more than the other function. So anywhere else we can conclude that the red function will be 3 times more than the blue function. Okay, let's solve this algebraically now. So to back up what I said earlier, I made a table of values and compared the two functions with the same x values and solved for the instantaneous rate of change. The values I chose were 0, pi over 3, pi over 2, and pi. We can see at the table that 3 sine x has a 3 times larger instantaneous rate of change with the values 0, pi over 3, and pi. This is because what I said about the amplitude stretching it 3 times more than sine x. Also, we see that at 2 pi, there are the same instantaneous rate of change. This is because here both of the functions are at its peak and both are parallel to the x-axis, meaning that the instantaneous rate of change are 0. So let's see how I got this. This is the rate of change formula I use. I'm going to refer to IROC. IROC equals f of x plus h, which is a small value. We use 0.001 minus f of x all divided by h. I'd like to note that this is an approximate formula which will become apparent as we continue. Okay, so let's move on. For the first value of x, we will use 0. Again, here's the equation for IROC. We will substitute 0.001 for h, solving for sine bracket 0 plus 0.001 gave us 0.0099999, and solving for sine x gave us 0. Solving the algebra, the answer comes to approximately 1. So now let's look at IROC for 3 sine x at the same x value. Again, here is IROC formula. Using 0.001 for h and solving 3 sine x at 0.001 gave us 0.002999999, and sine 0 is 0. Continuing the algebra, the final answer is 2.99999, which is approximately 3. Therefore, 3 sine x has a 3 times larger instantaneous rate of change, and this is because what I said earlier about the 3 times bigger amplitude. So I'll just give you some time to look at my solution. Okay, so I won't go over it again, but I did the same thing for pi over 3, pi over 2, and pi. For this one, pi over 3, I got 0.5 for sine x and 1.5 for 3 sine x. Again, 3 times bigger instantaneous rate of change. Now for pi over 2. I got 0 for both, which makes sense from looking at the graph because at this time, both functions are at its peak and parallel to the x-axis. Lastly, for pi, I got -1 for sine x and -3 for 3 sine x, which is perfect because they are both negative, because we saw from the graph that they are both going down at this point, and again, the instantaneous rate of change is 3 times larger for 3 sine x, proving that what I said before to be right. In conclusion, the question asked us if there are any values of x which the instantaneous rate of change of the two functions are the same. For that, we can say yes. Two values we saw just by the graph was pi over 2 and 3 pi over 2. This is at its peaks. So every time the function hits its max height or its lowest height, there will be the same instantaneous rate of change. This is because both do not have any vertical or horizontal shifts. We can also conclude that any other places on the graph where it's not at its peaks, 3 sine x will have a 3 times larger instantaneous rate of change than sine x because of its 3 times bigger amplitude. Thank you for listening and hope you enjoyed my video.